Good morning from Michigan. This is Ray Jeske. I will be presenting our top seal application. Overview of the webinar. Who is Nexthermal? Engineering services. Challenges in top seal assembly, technical information, and afterwards we will have a question and answer. Click the chat button to send your questions and they will be answered at the end of the webinar. Who is Nexthermal? We are an ISO 9001, 2015 registered, and UL listed. We have global reach in sourcing and manufacturing, industrial leading performance from design to delivery for custom solution. Here's our core products: coil heaters, controllers, sensors, cartridge heaters, and flexible tubular elements. We have fast, local, and high-quality heaters based here in Battle Creek, Michigan. We supply to North America coil heaters and cartridge heater, complete heating assemblies, supply of flexible tubular and Elstein infrared heaters, engineering services, and heat simulation. We have over 100 years of combined experience among our current staff and engineering team. What we like to do is be your engineering team or part of your engineering team. The people, our tools, testing, and facility. Top seal applications. And here are some of the products out there: hamburger bags, for instance, yogurt containers that all have some type of top seal. Some of the challenges in top seal. Applications with fan heaters or cast heaters, unable to seal bioplastic films and temperature-sensitive aluminum foil, leakers due to uneven heat profile, long heat up and response time due to high thermal mass and limited wattage, slowdown on machine speed, cycle time, and throughput, frequent change of heating elements due to washdown, market requirements to reduce carbon footprint, energy efficiency, and environmentally friendly packaging. Our response to the top seal challenges: thermal analysis, find the optimal form, fit, and function. With SolidWorks, we can do a heat simulation program. We can create a heater with distributed wattage, which results in developed thermal profile, improve heat recovery time, reduce energy consumption, and improve throughput and reduce downtime. We offer sealed head to prevent heater failure due to wash down and extend the life of the heater. This is an example where we're bringing the delta T down by plus or minus 25 F. just by switching to a distributed wattage heater, which is a standard Nexthermal manufacturing process. The example on the left has the set point about 465 degrees, where 86% of the jaw is a plus or minus 30 F. Of course, on the right, it's a plus or minus 6 F with the wattage distribution. And here's a cutout of a cartridge heater where you have more windings at the cap end and at the lead in, or in this case, the right angle. And that's how we distributed the wattage. It's a CNC control method. And then on the right is our anti-seize coating, and how we do that is we centerless grind the cartridge heater a little bit undersized in the diameter, and then when we apply the coating, we bring it back up to tolerance. This plate design using wattage distribution. We've got 8 cartridge heaters used in this plate. The plate's used for a top seal and portion packaging such as butter found in restaurants. You have a little bit too much wattage in the center of the heat, not enough on the ends, and on the after picture you can see that it's more evenly heated. Here are some of our flexible heaters and conductive material to improve the thermal profile. The minimum bending radius is 6 millimeters. It's flexible, hand formable, can be sealed For washdown applications, it's ideal for low mass, small footprint applications. Those are about the size of a hockey puck. We can incorporate a Type J thermocouple, positioned pretty much anywhere in that coil heater. Usually it's at the tip or the center. Rectangular profile for more surface area for heat transfer. And we can use a coil heater. We have a range between 3.2 millimeters or 1/8 of an inch to 6.5 millimeter tubular elements. And again, with 3.2, we can use a built-in TC. Our heater is designed directly over the sealing plate, eliminating any cold spots with a thermal profile engineered to deliver a superior seal. Nexthermal's profile coil heaters have proven to reduce leakers and increase the shelf life of customers' product. That's what we're showing here with the 350 degrees at the sealing surface. Nexthermal has engineered a thermally profiled top sealing system that can be tailored to your process. You benefit from our extensive R&D and with an optional top seal system that we can modify to retrofit your equipment. Nexthermal can respond faster to your equipment with a proven design customized to improve your process efficiency. Of course, this is another example where the engineering solution for various applications, flexibility of the coil heater allows you to form within a groove where the heat is needed. So our engineering services, number one, is to optimize performance. You must be careful to consider the heat location, fit to mating surface, material being heated, control method, cycle time, sensing method, and location, and the performance goals. So our services include production and product development assistance, solid modeling, design optimization for performance and engineering consumption, FEA, and lab simulation. This is an example of Nexthermal design, a complete mobile heating assembly which is able to kill bacteria by creating non-condensing, high humidity and high temperature environment. Due to new EPA requirements, one of our customers was required to switch to eco-friendly film. Their machines were unable to create a seal. They talked to us. We noticed their current sealer had a Delta T 26C. We were able to redesign the heating assembly to improve the temperature profile, Delta T of 3 Celsius, while still retrofitting the heating assembly. So this is a real-world example of common issues found in top seal applications. You see the big mass has to be heated, slow cycle time, more wattage needed. In this case, they're using band heaters. Here you see an inefficient design using cartridge heaters with a large mass. Inefficient results. Cartridge heaters can burn, may require frequent replacement of cartridge heaters. The heater here has a spring design, appears to be exposing the ceramic potting, which can cause a washdown failure. Another example of a cast-in tubular heater. Thermal break and non-circular shaft doesn't allow rotation, which may be necessary if the shape needs to be lined up the mating shape. Nexthermal's complete heating assembly solution. In many cases, your top seal mechanical equipment can run faster than your current heater will allow. We can put a coil heater that can form into a groove, putting the heat where you need it. The heater is compact, low thermal mass, faster recovery, integrated machine insulation, isolates the sealer from the heat sinks, reduces heat loss. Reduction in energy, anywhere from 30 to 50% reduction. And here's a cutaway of it. The replaceable heater with an internal TC tube is threaded to allow for a quick connect fitting and tubing. Tube can be extended to carry the leads out of the contamination washdown zone. The insulation material to focus heat to the steel face Got 4 silicone sealed, rated for 450 degrees F, and the spring to create the constant sealing pressure. Another cutout of it. Really like the colors here, the blue, red, and green. So here are some of our design considerations. You know, these different components, we have the global sourcing that we can get the material and offer the customer a plug-and-play assembly. Some more examples. The flexibility of the heater choices that Nexthermal offers is well suited for shapes in the packaging market. As shown in some of the following images, the package can be round, square, or any shape really, and the heater path can be adjusted to put wattage where needed to account for heat loss or where more energy is needed. Or in really small seals as shown where exactly heat is needed. Which top seal would you choose? We can also apply the packaging industry with thermocouples. We have great experience in it and a wide range of products that are available. I appreciate your time and thank you for participating in our webinar. Jeff Wheeler, our R&D manager, is now available for questions and answers. You can contact us or just click the box there and type in your questions and we will get to them as soon as possible. Thank you.
This is Jeff Wheeler, R&D manager. I also have Ray here and Flesh and Bud in front of me, and we're ready to take on any of your questions that you have posted for us. So the first question that's posted is, what materials do we work with? So I assume the question is based on the packaging materials. Obviously, the more complex the film, the better it is for us because we can really tailor the thermal profile of the assembly to really meet what the film's looking for. So as Ray noted in the presentation, a lot of the films are going more environmentally conscious and they require a tighter and tighter seal temperature control, what he referred to as delta T, which is a temperature difference over the seal length. That's really where we focus our expertise on. So as you're looking at getting into more green packaging, we have better solutions from an assembly perspective to answer your problems. Another question posted I have a donut shaped heater for our top seal application. Can you retrofit it with a heater as we're having sealing problems? Yeah, that's a common application for us. As you saw in the presentation, there are a number of different type of heater geometries that we can work with, and shapes and layouts and thermocouple locations, and even down to the materials that we choose. So yeah, there's all kinds of solutions for that market, and we'd be happy to talk to you. Another question posted, I have a 3.25 inch round sealing surface. How close can you bring the delta T for high temperature sensitive film we will need to use for one of our customers? I mean, as Ray indicated, we were able to get one application within 3 degrees C. I know in some cases we've actually been able to achieve even tighter control than that. A lot of that has to do with the geometry that we're working with and the materials that we're forced to work with. Like if there's some corrosion issues, we have to choose different alloys for heat transfer media, or where we can block the heat from going up or mounting locations to the machine. So it's really a case-by-case basis, but I can definitely tell you if you're using a tubular heater right now, we can outperform that. Can I get a copy of the presentation? Oh, yeah, okay. This will be posted as a video on YouTube, so absolutely. We'll post out a link to that and they'll be available for you to download anytime. And are you providing the entire sealing mold or just the heaters? That's a very, very good question. Something I was going to bring up. You know, in the presentation, you saw a lot of assemblies, and obviously we're a heater manufacturer, but that doesn't limit what we do. So we really integrate the heater into the assembly in the best way possible. The designs you saw on the screen were designs that we worked on, that we developed. The customer came to us with an application, came to us with a problem. We not only designed the heater, in some cases we designed the assembly the heater fits into for the best thermal performance. We actually prefer that because it makes our jobs easier. little self-indulgence there. The other side is if you have an existing application and you're just looking to improve it and we're not able to change materials, as Ray talked about in the presentation, we're able to change the distributed wattage to account for heat losses and try to improve what you have today. So yes, we could do the complete assembly, or yes, we could do the heater. Depends on the scope of the project. Ray, you have a comment?
And part of the way this works is it takes us roughly 10 days to build the heating elements. So we're sourcing the different components and then having them shipped here to Battle Creek. And in that time frame, we're building the heaters. So when the components come in, we can press in the heater into the groove of the material that we've sourced globally and put it all together. And that's where the term comes that when we deliver that to our customer, it's ready for them to connect the power and the thermocouple to their system, and they're up and running. And of course, we warranty our manufacturing.
Okay. Next question, is it energy savings? By how much? So we have had experience with customers that are looking to save energy in their application. You know, the heat is one of the biggest power draws on any kind of packaging equipment. Next to motors, it's typically the second highest energy consumer in the production line. So the more efficiently you can use heat in the application to perform the work needed, the better off the system is going to be. You know, obviously consuming less power. So yes, we have energy saving systems out there. We have different types of heaters that we use that can give up to 25% or even higher energy efficiency just by changeover. But really, you know, the video that we showed in the presentation of how that device was heating up really brings the point of the impact of targeting the heat to the application and controlling where the heat can move to if it's not to the film that you're trying to package. So you saw in there, we're using a coil heater, we're heating a low mass puck, you know, that we have a thermal break on top of that, so the heat's not rising up through the entire assembly. And by doing all that and reducing the mass, you can reduce the amount of wattage needed to heat the device, and you need less power to move. In the top sealer, you need you know, power in the motors to move the system. So you can save weight that way also. So yes. Next question, what type of heat sinks do you have on movable parts and seals? We work, like I said earlier, we have a wide variety of materials we work with. You know, obviously stainless is a very good thermal break. There are some versions like titanium that we can consider. Ceramics can be considered. Air gap is the most efficient and cheapest way of providing a thermal break within an assembly. So heat sinks, we have a lot of ways of blocking heat. Now, in terms of where the heater's embedded into, we do have a high performance alloy that we have identified and used in a number of top seal applications, which has a very high thermal conductivity, much higher than stainless steel. And it's also extremely high temperature oxide resistance too, so you don't develop scale at higher temperatures. We prefer to use that. There is a price premium to that material, but it performs very, very well. So in some of the more really challenging applications, we've moved to that material. Next question, can you retrofit the complete assembly we have? In some cases, yes. You know, the heaters that Ray showed in the presentation are our toolbox. You know, if you consider them that way, we can make modifications to the shapes and geometries, like the coil heaters that he was showing, the 3.2 millimeter coil heaters. Those are produced straight and they can be formed into a groove with a plastic hammer, a simple ball mill shaped groove. So yes, a lot of cases we can retrofit. It may not meet all the performance criteria that you're hoping to achieve, but we can start there and then make a decision whether it's worth investing more money or not in changing.
This is the last question.
And last question is, what are your lead times for complete assembly? Very good question. Ray, how do you want to answer that?
Again, the heating element is what we have the most control over. That's a 10-day lead time to manufacture the heating element. The different components, depending on where we're sourcing them from, on average, it's going to be probably closer to 6 weeks 6 to 8 weeks. And, you know, as far as a prototype assembly, where, you know, you're only looking at maybe 1 or 2, we can do that in roughly 2 to 4 weeks. And that way the customer can have an opportunity to test our design, you know, for their application. But if we're looking at, you know, larger quantities, longer runs, as a general rule, 6 weeks is an average time frame.
Yeah, it depends also on the level of complexity. Let me add on to your comment, Ray. You know, obviously, if we're talking about a very complex part that has to be machined and sourced and assembly put together, it might go 10 to 12 weeks. It just might. We don't really know until the model's generated and we get the product sourced. And usually the design phase takes a significant amount of time in this process. So we have to put that off to the side also. But it's a very good goalpost to have. There was a question, there's more coming in, so it's good. Is UL available on these heaters yet? So we have UL on the cartridge heaters. We also have UL on some of the sizes of coil heaters. The 4mm diameter, we do have a UL listing on that product. We are the only company that has UL on those small diameter flexible coil heaters. So absolutely. It's a matter of if the design can take that type of heater, we could certify it as UL 499. Questioning, how is a complete assembly cost compared to what the customer is paying now with your new design? Well, the cost is a subjective term. So the cost of operation, cost of scrap in production for poor seals, cost and energy usage. If you compare all that to the cost of the assembly, yeah, our assembly might cost more money, but the operation cost and the scrap costs will be a positive impact against that cost. So you really have to look at the entire balance of, you know, the cost versus benefit.
And one of the things that we always like to start with is a target price. And, you know, in the case of some of these examples that we've shown, if the customer is already paying, you know, let's just say $500, and I'm just using that as a generic number, then we know that we need to get the element, you know, the sensor into that, and then the different components. And as we look at that picture, then we finally get to a point where, yes, this is doable. We can accomplish this assembly for that price range. And of course, you know, there is occasion where we can't do it, and we're very honest and upfront and saying at that target, we can't offer you a solution.
Okay, that looks like all the questions we have. Is there any more that came in? No? They're all very good questions. I appreciate all the back and forth here, and I hope we clarified any concerns or any thoughts you had. If you have anything further, there is an email address listed there on the page, as well as a phone number. Please feel free to reach out to that. Again, this is Ray and Jeff, and we appreciate your time today and hope you guys have a great rest of your day.